Why does Schrödinger's cat need the observer effect? Imagine a tiny box sitting quietly in a lab, with a cat inside that's both alive and dead at the same time. Sounds strange, right? This thought experiment by Erwin Schrödinger was meant to show how weird quantum physics can be. Now, the question is, why does this experiment relying so much on the observer effect? To understand that, we need to look at what the observer effect in physics really means. It's about how measuring or observing a quantum system actually changes it. And like everyday objects, quantum particles don't have definite states until someone looks at them. They exist as a mix of all possible states, called a superposition. In Schrödinger's experiment, the radioactive atom inside the box can decay or not decay, and this decides if the cat is alive or dead. But until someone opens the box and observes, the system stays in that superposition. The act of observing forces the system to pick a single state. This is the core of the observer effect. It's not about a person's thoughts changing reality, but about how measurement interacts with quantum particles. When you measure, you cause the wavefunction, which describes all possible states, to collapse into one definite outcome. So the cat isn't just both alive and dead in a magical sense. It's in a superposition because no one has looked yet. Once you open the box, the superposition collapses, and the cat is either alive or dead. This idea challenges how we see reality. It makes us ask if the cat really exists in a definite state before observation, or if the act of looking is what creates that reality. The experiment was meant to question whether quantum superpositions only happen at tiny scales, or if they could apply to larger objects. It also raises the question of whether the observer's role is necessary to resolve quantum uncertainty. The strange part is that in the quantum world, things are not set in stone until measured. This is why the observer effect is so important for Schrödinger's cat. It shows how the act of observation is tied to the very nature of reality at the smallest scales. In real life, this principle underpins technologies like quantum computers and quantum encryption, where measuring a quantum bit changes its state. So, Schrödinger's cat needs the observer effect to illustrate how measurement influences the outcome and how reality at the quantum level is different from what we see in everyday life. It's a quirky, mind-bending way to show that the universe's tiniest parts don't settle into a single state until someone checks.